Part 2 of the Exam 2 prep. This is Math 1314, Lone Star College, Kingwood. Okay, so let's look at number 12. Here's a rational function or fractional function we are to solve. It's important to understand or think about what you're required to do. It's not graph, it's solve. So we want to get all of the x values that make that true. Now we've in the previous video we explained more of the theory behind this, but what are our important numbers here? Okay, well, zeros at the top and zeros at the bottom. Okay, we'll explain why. But the 0 at the top is obviously 4, because then you have 4 minus 4 equals 0. And it's important because that makes the whole thing 0. And 0 is less than or equal to 0. And the other one is negative 2. That's a 0 of the bottom. That makes the bottom 0. Okay. So we'll make our big number line here. Negative 2, 4, and so our intervals are everything to the left of negative 2, everything between negative 2 and 4, everything to the right of 4. Negative infinity to negative 2, negative 2 to 4, 4 to infinity, and the solution set will be some union of these intervals. Now, the endpoints, that's another issue. What is 4 included? Is negative 2 included? Well, we can kind of look at it from the beginning and see that 4 does satisfy this thing. Okay, so 4 is going to be included. So in Miller style, I will say included. But obviously, the negative 2 is not included. Okay, not included because negative 2 makes the bottom 0. Now we're dividing by 0, and you can't be a solution if you make something undefined in the problem. Test points. Okay, so let's try to make a good chart here. That's terrible. It's amazing how poor my artwork is. When in class, it's good-ish. Okay, so test point C, then we'll get f of c. We'll see what sign it is. In fact, let's just say sine of f of c. C, test points, just any old number that we like in these intervals. How about -3, 0, and 5? F, of course, is this function that we were given, the left-hand side of the equation. Okay, so here is all of this stuff here is f of x. Okay. So sine of f of c for x equal to -3, that's going to be a negative over a negative, so it's going to be positive. I'm sorry. Yeah. I said positive and then I wrote negative. Equals a positive. In other words, the number 7. But all that matters is that it's positive. For x equal to 0, we have -4 over 2. -4 over 2, which is a negative. And then for 5, we have everything positive, so positive. Okay. So now we've got results for these intervals. And so the question is, which are the winning intervals? Which ones get to be in the solution set? Part of that union, which is the solution set. Well, in order to answer that question, we have to look back up at the original inequality, and it's a less than. We've got a less than there. And so the negative, that's the winner. The other two are losers. And so -2 to 4. And remember that the 4 is included, but the -2 is not included. So the answer is the transformations. Okay, this one's going to be a 3-stager. Open, and stage 1 is going to be the graph interval of the parent -2, as stage 1 always is. And that's going to be y1 equals square root of x, which looks like that. And that's a graph that we have memorized. Stage 2, we're going to go inside out. Okay, we always go inside out. So we're going to deal with the -3, and then we're going to deal with the 1. Inside out. Okay. So stage 2, y2 equals the square root of x minus 3. The replacement of x with x minus 3 means that we have a right shift 1, 2, 3 units to the right. Finally, we'll deal with the plus 1. So r of x, that's the last one, y3, which equals r of x, which is add a 1 on there to what we had in stage 2. Well, that's going to raise the graph one unit. And that's it. Full credit. There's the graph. You've given the reader enough, reason to think that you know what the graph looks like. It's entirely in the first quadrant. Calculator would verify that. Another transformation problem. This one's also a 3-stager. When we replace x with x plus 2, is it going to shift left or right? Of course, we have to have a correct parent function, which is the squaring function. And so stage 2, replacement of x with x plus 2 shifts the opposite way that you might think. This is going to be to the left. So 1, 2 to the left. Then we got the minus 3. Is that up or down? Down. So the vertical transformations are the way you think they should be. So that's kind of a helpful thing to memorize, or to remember. I don't want to say memorize, but the vertical transformations are the way you think they should be, but the horizontal ones are the opposite of the way you think they should be. So we're going to go down 3 from what we have in stage 2, put the vertex down here. Same parabola, same shape, same wideness, but it's just been shifted downward 3 units. This one we could do in a 2-stager, but we're going to do in a 3-stager. Start with y1 equals absolute x, V-shaped graph. Y2, stage 2, will be multiply this by 2. So y2 equals 2 times, and I'll deal with the negative in the last stage, 2 times absolute x, and the effect of the 2, the multiplication by 2, is to narrow the parabola. Okay. I'm going to make that look a little bit better. Sorry. And finally, we have the multiplication by -1. That'll be the final stage. Y3, which is t of x. That's take what we had in stage 2, multiply it by -1. Just take the negative of that 2 times the absolute value of x. The multiplication of a function by -1, the result of that is a reflection through the x-axis. So it's still a skinny V-shaped graph, but now it's downward opening. This is going to be like the previous one, except that the V, because the multiplication is by 1/2 instead of 2, a number less than 1 we're multiplying by. Well, when you multiply by a number less than 1, stage 1 is the same. When you multiply by a number less than 1, the effect is vertical compression. So that V is going to get wide. And we exaggerate maybe the width of it for the sake of the reader, so the reader can recognize that it's a vertical compression that has happened. It's best not to call that a horizontal stretch. It's better to call that a vertical compression. Vertical stretching and compression is what happened when when multiplication happens on the outside. When multiplication happens on the inside, that's where the horizontal stretching and compression is. So y3 is v of x, which is the multiply what we have in stage 2 by -1. Reflection through the x-axis. Composition of functions. Evaluate the function for the given values of x. F of g of x. Now we recognize here that, they might have said it this way. They might have said f little circle g of x, and that would be the same thing. We would do exactly what we're going to do. Okay. F of g of x. Now the input is a function this time. So what is f of g of x? Well, f of anything is -3 times that thing. That's what f is. F is the multiply the input by -3 function. That's what f is. Well, what's the input? The input is g of x. G of x. But what is g of x? Again, f multiplies its input by -3. That input is g of x. What is g of x? Absolute x minus 2. Absolute x minus 2. Of course, we don't need those parentheses. And so the answer is just -3 times the absolute value of x minus 2. Okay. 18. F composed with 17. That's the answer to 17. Now, we could treat it like 17 and get f composed with g of x, which actually we already have. And then use that to get f composed with g of 5. Or we could get, in fact, let's do that. Okay, so f composed with g. There's another method that we'll save for number 19. F composed with g of x equals -3 times the absolute value of x minus 2 by number 17. Okay. Well then, f composed with g of 5 is, plug in 5. -3 times the absolute value, 5 minus 2, which is -3 times the absolute value of 3. What's the absolute value of 3? 3. That's what gets multiplied by -3. And -3 times 3 are 9. So 9 is the answer. Okay. Now, what we could have done is found g of 5, get a number for the g of 5, and plug that into f. Run that through f and get the 9 that way. Okay, so g composed with we'll use that approach by the definition of the composition of functions. This is g of f of 5. Well, let's just get a number for f of 5 and then run that number through g. Okay, so G is going to sit here waiting for a number, because f of 5, I mean, that's an easy problem. If we just, block out everything except this f of 5 here, we realize what an easy problem that is to get a number instead of f of 5. Okay, so this f of 5 here, well, by the time I can draw attention to it, you already realize that f of 5 is negative 15, right? Because f is the multiply the input by negative 3 function. And so this f of 5 here is negative 15. We're going to take negative 15, we're going to run it through G. G subtracts 2 from the input and takes the absolute value. So absolute negative 15 minus 2, which is the absolute value of negative 17. And of course, absolute value, if the inside is negative, absolute value changes the sign. Only if the input is negative, or the inside is negative, which it is in this case. So 17 is G composed with f of 5. Now we could have treated this like 18 and found G composed with f of x and then plugged in 5. But that would be doing work that we didn't have to do, and it's easier to do it this way. Just get a number for f of 5 and go from there.